What's going on, guys? Welcome to another video. This one is on a tool that I think is one of the most useful sysadmin tools that you can learn. It's called lsof, L-S-O-F, and that stands for List Open Files. It basically asks your kernel to give you a list of all open files, you guessed it. It's really useful for exploring what's happening with the file system on a given system or for a specific process. If you're impatient and you just want to see the commands, just open up the description to this video. You'll find all the commands there. The prerequisites are fairly simple. To understand this video, you're going to need some very basic command line skills. If you're not sure if this is too advanced for you, just give it a try. And if not, you can look at some of the basic command line or shell videos below. lsof, without any arguments, just gives you an enormous list of files that your kernel sees as open. I'm going to stop that before it totally overwhelms us. Let's go through what all of these columns mean. So I'm going to just say head, just to get a few lines. And we can see the header here sort of explains it. So this is actually the file, the address on the file system, the path that we're interested in. So it's the name. We'll start at the beginning. Init is the name of the command that was run. This is the process ID, the user that it's running as. The file descriptor, CWD is current working directory, meaning that this is inside of where the program was started from. TXT means like program code, mem, etc. We're not worrying about that in this video. I'm just going to show you the very practical stuff here, stuff you can use right away. The type, the actual physical device that it's on, the size. On some Unix systems, this is like offset for reading or writing, so where in the file it is, but here it's file size. And then the inode, or the file's address on the file system. And then the path. So 99% of the time you care about this, the actual path of the file here, or you care about the command or process ID. That's like 99% of the time you're going to want the first column, the second column, or the last one here. So that should give you some idea of how to just parse this output. A lot of the time you'll be grepping through this output, so you won't see this heading. So just kind of like internalize that. It's pretty self-explanatory, right? Like init, okay, process one, okay, and here's the thing we're looking at, some shared object, so some library. So at the most basic level, I'm gonna show you all of this in the context of Nginx. You can see that we've got Nginx running, listening on port 80. You can curl localhost and you'll get, I think it's like some kind of WordPress test site or something. Yep. The first thing you can do is, we all know that var log has an Nginx log file inside of it. You've got your access log if you've got that turned on, and your error log. So we're going to be interested in the access log for now. So if you just pass a single argument to lsof, the path to a file, it will tell you which processes have that file open. So if you say lsof var log nginx whatever access log, this is the output it gives you. So it's saying, oh yeah, you want to know who's looking at this file, what's going on with this file. So you can see the command, obviously nginx, the process ID, all the processes that have this file open, that have a file handle. You can see that this is like the main Nginx process that you originally started. It's privileged, running as root. But then all the data unprivileged processes that Nginx spawns to actually deal with untrusted communications with the outside world, so actual requests coming into the web server. You can see the file descriptor that's open, file descriptor number, and then this number here will be like R for read, W for write, or U for read-write. So you can see that this is these processes don't care about reading from this file. It's an access log, so they just write into it. They just poop out log data into that file. The type, again, not worrying too much about this, right? It's on the same physical device. Size or offset, and here's the actual inode, so the address on the file system. And obviously it's all the same file because we asked for this specific file. Now let's ask another question. We know which processes have a given file open. That's one of the easiest lsof commands, just lsof path to file. But how do we find out which files a specific process has open, because that might be more than a single file. So we'll say, first we'll just, you could use pgrep for this too, but we'll just pick one of the Nginx like worker processes here. 1193 or 1192 looks good. So we'll say lsof p for process, and then we'll say 1192. We'll have to scroll for this one. So you can see we've got, this should be a txt. This is like actual program code, and that is the Nginx binary that it's got open. All these SO files, these are shared like library files. This would be like DLLs in Windows. We've got dev0, dev null. We've got it writing out to the error log. Now these numbers are significant, right? 1, it doesn't care about. 2 is standard error. And 3 is standard out, which is a socket. Those first 3 have a meaning. If you're not sure about that, just look at the Wikipedia page for file descriptors. Another handle on error log. And then you can see we've got something a little bit more special. These are sockets. We'll look at network sockets a little bit later, but for now, just if you don't know, Linux represents network sockets as regular files. Everything is a file on Linux and Unix, and it's sometimes wonderful, sometimes terrible, mostly wonderful, and it makes it easy to see, what a process is doing on your system. So it's got a couple of TCP sockets open. Obviously, it's a web server, so that makes sense. You can even see the protocol here. It's listing for HTTP. Okay, so there's your list of what files is this process touching right now. What is it reading from, writing to, or both? This is a lot of data to parse. I mean, I just sort of worked through some of the basics here, but you could just pipe this and grep through it. So you could do something like this, say, okay, fine. I'm actually just looking for bin. So in the case where you're like, I know this thing is running, I have no idea where the last sysadmin put this software that he compiled himself, and it's like hidden somewhere in God knows where on the system, var temp something, and you need to access its config files or whatever. This is a good way of finding, okay, where's that binary? Where, what shared libraries does this thing have open? There they are. I didn't make that a literal, but grepping for shared object files. Likewise, where is this thing logging to? Well, this is a sort of easy cheat for doing this. You can see that in this output, you can pretty much make some educated guesses for what to grep for, and very quickly get an answer like, where does this thing live? Where's the binary? Where is it logging to? There occasionally are better tools for what I'm showing you how to do here, but I'm trying to teach you lsof, and it's a good hammer. It's really versatile. It lets you do a lot of stuff, and because processes mainly interact over the file system, this is a really nice way for getting your pulse on kind of what something is doing. Now I'm going to show you the inverse of one of the things we just did. You know how to see which shared libraries something is using by just doing a lsof on that process ID and then grepping for .so files. Pretend, for example, that this library just had a vulnerability and you just patched it by grabbing a new version, and you suspect that some services were not restarted and they're actually still hanging on to this old version of the library, let's say. So to find out what's still hanging on or reading from or dealing with this file, this library, you could just do lsof and then use that as your path. So that was one of the first things we covered, but you can see you've got a bunch of www data processes that are using this libssl library. So you would know, okay, I got to restart Nginx here, and then they'll catch on and release their file handles on this thing. Now let's spy on our users. If you've ever wondered, you've been on a multi-user system and you've wondered, what's this guy up to right now? Well, you can check which files a user currently has open. So you could just say lsof username. Obviously, I'm running a graphical user interface, so I have a ton of files open. However, you can see that this user might be doing something a little bit strange, something you might want to look into. If you're interested in seeing a specific kind of file, for example, a network socket, I'll show you the most simple version of this, lsof I port 80. That shows you which processes have something listening on port 80. You would also see the state here, so like you might see established, that kind of thing. You can also look for a specific protocol. So you could say TCP, you could say, it's going to take a while, UDP, there you have it. So this is a very quick way of finding out if you've got some target port or something, to find out what is listening there. You could do that with SS, or if you're using IP tools, you could use netstat. But this is a nice, quick way of doing this. So that's your quick overview. There's a lot of common problems that you can solve using lsof. I use this on an almost daily basis. For example, the other day I had just forced a log rotate on an HA proxy server that deals with a ton of traffic. We keep an access log for that HA proxy server. That access log grows to several gigabytes a day, 4 or 5 gigs a day. Another process takes that log file, ships it off to like a reporting, monitoring server, that kind of thing. Well, the problem is, when I was running low on disk space on that machine, I forced a log rotate, which compressed and moved that log. So the file was actually gone, and I was expecting something like 8 gigs of free space, and I did not have 8 gigs of free space. So I was just using DFH to see free space, and although I was deleting things, my disk use percentage just wasn't going down. So what I did was a lsof on that file. That showed me which processes were still hanging on to it, even though it wasn't being shown with a list anymore. The file was quote unquote gone in the shell, but it hadn't been actually deleted from the physical, from the file system yet, because that log shipping process was still hanging on to that file. So it's just a simple example of how several processes interacting with one file can give you some weird results that you can easily troubleshoot with lsof. So you know a whole bunch of stuff now. You can check which files are open and do any number of greps on that output to find what you're looking for. You can check how many files a specific process has open. You can check which processes have a specific file open, or which files a specific process has open, sort of the inverse of that. You can check, again, by just looking up or grepping through the results from a single lsof p and then the process ID, whatever number that is. You can grep through that and find very easily things like where the binary might be, where the log file might be, kind of what it's doing on your file system. You can investigate some strange interactions and mysteries that happen from multiple processes interacting with a single file. You can check what users are doing on the file system. You can check what's happening with your network sockets, who's using them, what processes are using them, and down to the protocol that you're interested in. So that should give you a fair amount of tools, really, with a single command and just a couple of switches. I've kept it to sort of the bare minimum for using this competently. So think up some problems and use it to explore some stuff that maybe you're not totally familiar with. If you're running top or htop and you see some stuff, this could be a nice way of exploring a process that's running on a system. So if you don't really know how MySQL does things, well, you can check 1184. And you can forget the -p, like me. Be cool like me. And you can see, what's MySQL doing? Apparently quite a bit on the file system. So this is a way of kind of learning a whole lot more about what's going on your system. It gives you a lot of visibility for the file system layer of your operating system. So have fun with this. Use it to explore and play with this. Actually go and use all these commands. Otherwise, you're just not going to remember this, and this has been a huge waste of your time. So I'll see you in the next video. I hope that's useful. Leave a comment below with questions or fun shortcuts or variations of this command that you like that are useful to you. And I'll see you guys in the next one.